All right, let's take a look at number 37 here. It says for each of the following sets of numbers, find the equation of a function in standard form that has these roots. All right, so let's take a look at letter A here. I know that if my roots are 3 and -7, if my solutions are 3 and -7, then I have x minus 3 as one of my roots, and I'm going to have x plus 7 as one of my roots. And so we are coming up with a function or an equation, so we'll just say, okay, well, y equals, and now we're just going to go ahead and multiply these through. So x times x is x squared. I have x times 7 is plus 7x minus 3x, so that's plus 4x. And then I have -3 times 7, which is minus 21. And so for our first function with these two roots, we end up with y equals x squared plus 4x minus 21. All right, let's take a look at letter B here. We do the same thing here. So for the first root, so we're going to say, well, y equals, because we want a function. And so this will be x, and this will be minus 4i for the first solution. And then for -4i, we'll have x plus 4i. So again, keep in mind over here, if x was 3, then my factor is x minus 3. And if x was -7, well, then our factor was x plus 7. So we just do the opposite here. And so that's what we're doing. This is plus 4i or positive 4i, so it's x minus 4i. So now we can go ahead and distribute this. We get y equals x times x is x squared. I have plus 4i x, so let's go ahead and write this out. Plus 4i x minus 4i minus 4ix, and then I have negative times a positive is a negative, 4 times 4 is 16, and then I times I is I squared. If you recall, we said that I squared is also equal to -1. And so what we see here is that this plus 4ix minus 4ix, those will cancel out, and we basically just end up with y equals x squared. Now keep in mind this is a -1. So what this really means is this means -16 times -1, which is plus 16. And there we go. These middle terms canceled out. There is my function given these roots, given these solutions. Okay. So we'll do the same thing for letter C. So y equals, this will be x minus root 5 times x. This solution gives us x plus root 5. So now it's just a matter of distributing everything through. So y equals x times x is x squared. I have a plus 5 root, so plus root 5 x, and then I'm going to have a minus root 5 x, and then I have a negative root 5 times positive root 5 is just minus 5. My middle terms cancel out, and so we just end up with y squared, or y equals x squared minus 5. And that is our function in standard form. Now, for D, E, and F, you'll notice that with these complex numbers right here for letter B, or these square roots, there's a theorem in algebra where if you have the plus, you'll have the minus as the roots. They have to come in pairs. And so that's why we learned about what a conjugate is, because if this has a solution of 1 plus 2i, then it also has to have the solution of 1 minus 2i. It has to also include the conjugate. All right, so this is going to take a little bit more work, but let's go ahead and look at this. So I'll go ahead and work out this first one, and the other ones I'll kind of go through a little bit quicker. So this would be the equivalent if we said, okay, well, let's go ahead and basically say that x equals each of these, right? So x equals 1 plus 2y, just like we would do up here. X equals 3, so we know x minus 3 equals 0. And then I also have x equals my conjugate, which is 1 minus 2i. Now remember, to get our factors, we want to go ahead and set these each equal to 0. So we just move everything over. I have x minus 1 minus 2y equals 0. That's one of my factors. And then we move everything over here, which is x minus 1 plus 2i would equal 0. Now, here are my two factors, and what we have is a difference of squares. So off to the side here, let's go ahead and look at something that we need to help us. A squared minus b squared is a plus b times a minus b. So we're going to use this difference of squares, or we can go vice versa, right? So basically what we see here is, let me go ahead and use red, is I have my a is going to be x minus 1. Okay, that's going to be my a squared. And then I have minus my b squared, which is basically going to be this 2y minus b squared. And so what we're going to do is we're going to use this difference of squares to basically help us multiply this trinomial times a trinomial. Now you could go ahead and distribute everything through. That would be pretty messy. When I take a times a, I get a squared. So this is going to be x minus 1 squared minus my b term, which is 2i. So 2i times 2i is 4i squared. So there we go. We just multiplied this through, and we can take x minus 1 quantity squared. Again, another difference of squares. So this will be x squared, and this will be minus 2x. Negative 1 times negative 1 is plus 1. And keep in mind here, we said that I squared equals negative 1. So negative 4 times negative 1 is plus 4. So my polynomial becomes x squared minus 2x plus 5. So here's what this means. This means if you plugged in this polynomial, this quadratic expression, into your quadratic formula, when you simplify everything, you end up with a 1 plus or minus 2i. That's what this means. All right? So this is a pretty complex problem, and for those of you who are kind of seeing what's happening here, go ahead and follow through with the next two. This isn't something that I think you'll be tested over, but I think it's important that you see this, because when you get into trig and pre-calc, you'll need to do some of these more complex things. So I wanted to expose you to these three types of problems. All right, so let's go ahead and look at the next two. The first thing we're going to do is go ahead and identify our conjugates, right? So this will be negative 2, I have plus 4i, so this would be negative 2 minus 4i. And then over here, I have 3 plus I. And so we can go ahead and do the same things we did here, where basically I have x, and I'm just going to move everything over. So it's be plus 2 minus 4i times, this will be x, when I move everything over, it's going to be plus 2 plus 4i. So again, we're going to see a difference of squares here. We're going to see this x plus 2 out front. And then we're going to see this minus 4i plus 4i. So we're going to kind of use our shortcut here. This is a squared minus b squared. So this is x plus 2 squared minus 4 times 4 is 16 I squared. And we can go ahead and take x plus 2 times x plus 2. That's x squared plus 4x plus 4. Keep in mind I squared is negative 1, so negative 16 times negative 1 is plus 16. So when I combine all this, it's x squared plus 4x plus 20. So again, if you plugged in a as 1, b as 4, c as 20 into your quadratic formula, you're going to get a negative discriminant, and when you go ahead and simplify all this down, you end up with negative 2 plus or minus 4i. So you have two complex roots as your solution. All right, last problem here. Same thing, we're going to do x, and we're just going to move everything over. So it's going to be minus 3 plus I as one of our roots. And then we're going to have x, move everything over, minus 3 minus I as our other root. We see that we have x minus 3 as our a. So this would be x minus 3 squared minus I squared. And so this is x squared minus 6x plus 9. That's what x minus 3 gives us. And then we have minus I squared. Well, that's minus a negative 1, so that's plus 1. So we have x squared minus 6x plus 10 is our polynomial. All right, so D, E, and F are going to be good for those of you going on to trig and pre-calc. This is stuff that you're going to need to do. I'm not going to test you over this in Algebra 2, but I do want to expose you to it so you can kind of see. I think for some of you, there'll be several of you that can handle D, E, and F. All right.